Hello, I'm Thanh, Bioinformatician in the core bioinformatics support group at Quadram Institute Bioscience. Thank you for having me an opportunity to share with you about our showcase of using Nextflow on automating a bioinformatics infrastructure for processing and analyzing SARS-CoV-2 virus at QIB over the past 2 years. Just a brief introduction of the context before we're getting into the main topic. So back in March 2020, when the SARS-CoV-2 started introducing into the UK and then quickly spread widely within the country, around the later March, a COVID-19 Genomics UK consortium was established to fight with the pandemic. QIB then became a core academic partner of CORE UK, focusing on pioneering new experimental methods that would allow for rapid virus detection to improve the population testing and surveillance of SARS-CoV-2 in the environment. We also provide sequencing analysis capacity on the viral genome. Our experienced scientists then developed the Corona Hit, a method for sequencing at large-scale multiple viral samples that can be over 1,000 viral C genome on a single Illumina NextSeq run. Typically, a sequencing project has 3 main stages: sample preparations, sequencing the samples, and then analyzing sequence data. Each stage has its own challenges, but bioinformatically, for the analysis stage of the SARS-CoV-2 virus, we need to provide a quick turnaround, essentially as fast as possible. This stage involves many steps, such as processing sequence data, validating the sequencing quality of the data. We also need to provide a report of the viral variants from the sample populations or any mutation of interest. So, we consider 2 aspects of the infrastructure to work on this challenge, which are computing environment and the bioinformatics pipeline. For the computing infrastructure, it was deployed based on a private cloud using OpenStack cloud software located at QIB. This cloud infrastructure is part of the Cloud Big Data, which is a 5-year initiative to provide cloud-based compute storage and analysis tools for microbiologists across the UK. In order to make a scalable and reproducible computing environment, we use Terraform. This is an infrastructure as code tool to provision a cluster including virtual machines, a virtual network, and virtual storage volumes. By using Terraform, we can easily scale up, or in other words, is increasing computing resources by changing a few parameters in Terraform code. For example, if we want to add more virtual machine into the cluster, we can simply change the count value at the line 131 and vice versa for reducing numbers of computing nodes in case we don't need to occupy large idle resources. For managing computing jobs, we use SLURM, an open source job scheduler which is quite popular at many HPC facilities. However, setting up SLURM manually is probably quite painful, but thanks to the project Elastic Cluster, installing and configurations of SLURM via Ansible is pretty easy and quick. So from these chosen open source solutions, we were able to build programmatically a scalable, reproducible, and robust computing infrastructure that is used for running our COVID bioinformatics pipelines. Based on requirements for the results from our working group, we identified components in the pipeline that can be automated that are colored in green. So we need to have a pipeline being able to listen when the sequencer finishes. It will automatically kick off the demultiplexing to generate FASTQ files from the raw BCL imagery format. If the samples are labeled as core project, they will be dispatched to the COVID-19 pipeline to assemble viral genome for each sample. Afterward, the viral genome will be dispatched to other pipelines for further downstream analysis. For example, identifying the global lineage, UK lineage, as well as to evaluate the sample sequencing quality, like if they were contaminated or has sufficient coverage for being reliable the result. So the results will then be populated to a central database so that our working members or collaborators can access for further analysis. To have a quick decision if the run was good or needed to do further work, the results and also sent over a Discord server where our working members can read the reports instantly using either mobile device or computers. From this conceptualized diagram, these are the tech stacks we chose to implement the bioinformatics infrastructure. Actually, many members of the core UK had already used a Nextflow-based pipeline, the COVID-19 pipeline, which was developed by Tom Connor Group at Public Health Wales Pathogens Genomics Unit for processing SARS-CoV-2 sequence data. Hence, now we decide to use it rather than to develop the unnecessarily similar one. The others were in-house developed using Nextflow DSL2. So in this infrastructure, we have 5 independent pipelines written in Nextflow. We developed a daemon in Python for orchestrating these 5 pipelines. We use Huey, a lightweight task queue for 2 purposes: writing a listener using the Huey cron job feature to monitor the running state of the sequencer, and to put all the pipeline into a queue before sending them to the SLURM computing environment. The queue states of Huey are stored in Redis and in-memory storage for fast querying. To make the pipeline able to communicate to each other, for example, once the demultiplexing step successfully finishes, it will talk to the COVID-19 pipeline to query any samples labeled as cork for producing the viral genomes, and so on. When the viral genomes are generated, other pipelines will be signaled to kick off. For such a mechanism, we use Mosquito MQTT, which stands for the Massive Queue Telemetry Transport, a public subscribed machine-to-machine network protocol that widely used in IoT or Internet of Things for communicating among the devices. Though the stack may look complex, implementing it is actually very straightforward and simple. I'm not showing all the code here, but just a feature of Nextflow we found is very convenient and saves us a lot of time to handle the running stage for each workflow. So, by including some Python helper scripts into the workflow on complete functions, we were able to make the pipelines talk to each other. For example, once the workflow completes successfully, it will send plots of sample quality and summary reports to the Discord server where our working members were waiting to instantly read them. It also sent a finished status to other pipelines to automatically kick off. To monitor run status of all the pipelines, of course, we use Nextflow Tower. This service is really helpful for monitoring jobs with very informative and beautiful visualizations, and we didn't have to develop another monitoring service that is a crucial component in an automated system. So once the pipeline is finished, we can instantly check results on our working group Discord. As showing a demo here, every time our well-loved colleagues press the start button on the sequencer, we bioinformaticians also await immediately the new coming data, and when the analysis pipeline finish, we can quickly check out how many samples pass our quality cutoff, or if we have something strange in the run. Even other downstream analysis results like statistical lineages, variants or mutations of interest of the sample population can be quickly reported. With such a fast turnaround, we were able to help provide useful information to public health authorities, epidemiologists. For example, we flagged unusual cluster from a single hospital, which was immediately investigated by clinicians and found to be an 11-ward outbreak driven by staff movements, leading to immediate changes in hospital policies. We identified transmission cluster between sick care facilities, resulting in recommendations to restrict movements of professional visitors between care facilities. Overall, we have this automated bioinformatics pipeline perform very robustly, and it has processed more than 87,000 genomes until late April. So, just a few comments from our experience of using Nextflow on deploying an automated bioinformatics infrastructure for the SARS-CoV-2 sequencing project at QIB. Needless to say much more about the awesome feature of Nextflow to the participant here, we highly recommend using Nextflow for quick building bioinformatics pipeline that can run a large scale, robust, and portable. Monitoring Nextflow job with Nextflow Tower is very helpful. This is a unique and beautiful feature that we haven't seen in any workflow manager ecosystem personally. And finally, I would like to conclude my talk by the acknowledgement to the support from BBISRC, SLURM, Big Data, COG UK, QAB, and all working members of the COVID sequencing project. This work could not have been achieved successfully without their contribution and feedback over the course of work. And thank you for your attention. I'm happy to discuss and answer any questions you might have.
Can you hear us?
I can hear you.
Perfect.
Perfect.
Awesome.
Nice to meet you guys virtually.
There's a question from Phil. How do you use those bots? Can the code be reused elsewhere? So I guess this is regards to the Discord automations, for example.
So for the bots, the bots label as bot, but actually it's a webhook from the Discord pipeline, and it's automatically kicked off and triggered by the orchestra daemon. And in terms of the usability, I mean the reuse, yes, it can be used, but currently we keep the code privately for security reasons because we do some hard code there, so not really available for public use.
Because we've been thinking a lot about how, like, mostly like a Slack integration, I think, with Tower could be a great thing, and it's great to see that the kind of thing's already been done. There's a question around, was Nextflow used at your institute prior to COVID? And or did you hear about it?
Yes, we do have server workflow, even NF for pipelines used before the COVID. But we also have other infrastructure. So we have wide spectrum of the informatics infrastructure at the institute. Depends on our purpose.
And then what are the plans for the future? Are you thinking of applying this and sort of more widely in terms of like genomic surveillance, or how are you thinking about the future work that you're going to be doing?
It's not about future. Actually, we still keep Ping is running at the moment, at least for the routine service. So, for example, when we have the routine sequencing service, the boss team working on that, pick up some steps, except for the COG data.
Awesome. Great. Awesome. Thanks so much.
Thank you.